Okay, we are going to talk about continuous probability distributions here in our next section. Continuous probability distribution is one where our event can take on any number, not just whole numbers, like we typically had with discrete distributions. Like when we're rolling a die, you get a number, a one, a two, a three, four, five, six. But in a continuous probability, you can get any number sort of at any particular time. It doesn't jump from value to value to value. You can have sort of fractional sort of things. And our first type of continuous probability that we're going to look at are the uniform distributions that you have out there. In a uniform distribution, every value within that range is equally likely, and uh, and so one of the ones that we can get to fairly easy is the rand command on our calculator. It uh, gives you any number between 0 and 1 with equally likelihood. And so we indicate that with a nice level straight line going across there. The height of that graph would also be 1 because the total area of any continuous probability distribution needs to be 1, that we have to have the area is equal to 1. And when we're talking about the probability under the curve, we're talking about the area under the curve within those intervals. So if I'm looking at the probability that on my calculator, I randomly generate a number between zero point 0.3 and zero point 0.5, I'm looking at the area of that little chunk there between zero point 0.3 and zero point 0.5 on our uniform distribution. Uh, the width of that interval, and it's going to be the area, and the width of that interval is zero point 0.2 units wide, and we know that the height is 1 unit. So the probability that I'm going to generate a number between zero point 0.3 and zero point 0.5 would be 0.20 or 20% in there. And just to see what that looks like, here on your calculator, you can find that under the math menu. And then there's a PROB probability one over here a few ways. You got a left arrow to that. And then it's the very first one here is the RAND generator. And every time you generate a number, it generates a number between 0 and 1. And so if we're looking at values that are between zero point 0.3 and zero point 0.5 out of these four. I've got one of them that's in that interval, and then that one's not, and then that's one not, and oh, that one's not, and that one's not, and that one's not either because I'm looking between zero point 0.3 and zero point 0.5. There's one between zero point 0.3 and zero point 0.5. But if we were to generate lots of random numbers like this, about 20% of them would turn out to be between zero point 0.3 and zero point 0.5, according to our model in there. And if we look at something like that, if we want the probability that you get something greater than zero point 0.9, well, so zero point 0.9 on our graph is here. So between zero point 0.9 and 1 it would be, and that is 1/10 of your overall distribution. So that would be 10%. So we're going to get a 10% chance of getting something between uh, uh, getting a random number that's greater than zero point 0.9 would be a 10% chance of that happening in there. Okay. Another common place where we tend to use uniform distributions are like with buses or trains or something like that. So if we have a train that arrives every 4 minutes, here's the picture of the trains that run at SeaTac Airport, the underground trains that take you out to the north and south satellite places out there. The trains run every 4 minutes or so, and so the time that you have to wait for the next train to arrive, a lot of times we think of that as a uniform distribution, where it's any time in there. Sometimes you don't have to wait at all. Sometimes you have to wait up to 4 minutes to do it there. But we like to think of that probability as being a uniform distribution, that any time is equally likely. And so we would again represent that with a rectangle, 0 to 4 here. But the height now that you're looking at is going to be 1/4 here. It's going to be 0.25. The total area that you have of this rectangle has to equal 1, and the length times the width has to equal 1. And so if the length is 4, the width has to be 1/4, or the height or whatever it is that you're looking at there. The height there has to be 1/4 in there in order for it to equal. Actually, I have W, but I should be using H. The height there should really be length times height gives you the area, and that area has to equal 1. But if the length is 4, then the height would have to be 1/4, 1 divided by 4, 0.25 in there. So if we're looking for the probability, you have to wait over 3 minutes. You're looking at this area in that last section of the graph between 3 and 4. I know that that section is, for that section, the probability that W for the wait time is greater than 3 would be the width of that value, which is 1 unit wide, multiplied by the height, which we calculated above would be 1/4. So you have a 25% chance that you have to wait more than 1 minute to that you have to wait over 3 minutes for the train to arrive. If you want to know what the probability is, you have to wait under half a minute. So I'm looking there on that uniform direct distribution. So 0 to 1/2 would be our width. Our height is still 1/4. So the probability of the wait time being less than 1/2 would be 1/4 times 1/2, which would be 1/8 0.125, or 12.5% chance. So you got a 12.5% chance of having to wait less than 1 minute for the train to come up. Some nice facts about these continuous probability distributions, as we've mentioned before. The total area has to equal 1. The probability that you look at any individual number is that um, is that 0. So the probability that you have to wait less than or equal to 1/2 is also going to be 0.125 in there. It doesn't matter whether it's less than or equal to. The probability of it landing at exactly half a minute when that train arrives, 30 seconds before that train arrives, is 0, that it comes out to be exactly 30 seconds. There's no width to that interval. You have to have a width in order to get those two. And the probability that x is between a and b is the area under the curve between a and b. That's true for all continuous probability distributions. For the uniform distribution, it would be the height of that graph multiplied by b minus a in there. And so that's the uniform distribution that's out there, and that's what our 6.1 things talk about, is the uniform distribution. So you're asked questions like these. Again, the probability that it's exactly 3 minutes or the exactly 1/2 minute would all be 0. And the probability that you're looking at in general for the uniform distribution, the probability that you're looking at, the probability that sort of A is less than or equal to X is less than or equal to B would be 1/2, or 1 over, well, it would be uh, the height of that graph. Let me just call that the H. Whatever the height of your graph is, times B minus A, times the width of your interval there that you're looking at. All right. Don't forget to upload your homework here in the next couple of days, and uh, do those problems out of the textbook. If you get stuck on a problem, you can ask a question, and I will respond in the chat.